Okay, Bismillah ar-Rahman ar-Rahim. Now we'll try to finalize this section 7.6. We did all the exam problems. Now we'll do the questions from the book. Yeah, I will start with this one, which is an easy one. What they want the general solution. They want me to find the general solutions of this problem. Find the general solutions. Yeah. Okay. So it means I need first to find the eigenvalues as usual. Find the eigenvalues. I have a minus lambda I. That will be what? 3 minus lambda minus 1, 1, 5 minus lambda, which is equal to lambda square minus 8 lambda plus 15 plus 1, which is plus 16, which is lambda minus 4 all square equals 0. So I have lambda 4, 4. Okay. Now for eigenvalues, for eigenvectors, which equal lambda equal 4, we have 3 minus 4, which is minus 1 minus 1, 1, 5 minus 1, that is 1, times k1, k2 equals 0, 0. So I have minus k1 minus k2 equals 0, and k1 plus k2 equals 0, which means actually I have k1 equal minus k2. So we have only one eigenvector, which is, we can write it, I can let k2 equal minus 1, then k1 equal 1. So b equal 1 minus 1. So what is d? D will be the multiplicity, which is 2 minus 1, that is 1. Okay. So d equal 1. Okay. D equal 1. It means we need now to try to find a minus, we need to choose u1 such that a minus lambda I square, u1 equals 0, but a minus lambda I u1 not equal to 0. Good. So let me find what is a minus lambda I. Yeah, a minus lambda I, that will be minus 1 minus 1, 1, 1. So it is a minus lambda I square. Product of that by itself, that give me what? 1 minus 1, 0. 1 minus 1, 0, minus 1, 1, minus 1, 1, 0. So now we'll choose u1 to be what? Yeah, as usual, we'll make it 1, 0. Choose u1 equal 1, 0, which for sure satisfy this, and this is 0. Any vector will satisfy it. And also it satisfy this. Actually, I'll find u2, which is a lambda I u1. That will be what? Minus 1, 1, 1 times 1, 0. It's minus 1, 1. Correct? Yeah, minus 1, 1. Okay. Now, what will be x1? So that will lead us to that x1 will be u2 e, what was my lambda? 40. And that is, what is u2? Minus 1, 1 e40. And x2 is u2t plus u1. And that is u2, say minus 1, 1 times t plus 1, 0 times e40, which is minus t plus 1, the other one t times e40. Okay. Yeah. So my general solution X will be C1 X1 plus C2 X2. Well, you list these. Yeah, it will be C1. What is X1? Minus 1, 1. X2, 1 minus T, and T. All of this times e to the power 40. Yeah. You can find also the first solution, second solution, if you want. Okay. Another example. We'll do the same. 2 by 2 is the easy one. This will be 7 minus lambda 1 minus 4, 3 minus lambda. That will be lambda square minus 10 lambda plus 21 plus 4, that would be plus 25, which is lambda minus 5 square. So lambda will be 5 and 5. Now for lambda equal 5, what we will get? Clearly we will get only one eigenvector. Okay, let us see it. So I have 2, 1 minus 4 minus 2 times k1, k2 equals 0, 0. So I have 2k1 plus k2 and minus 4k1 minus 2k2 equals 0. So from these two, I'm getting k2 equal minus 2k1. So I have only one free variable. So we have only one eigenvector. So that implies d equal 1. What is the eigenvector, by the way? Let k1 equal 1, k2 equal minus 2. So the eigenvector will be 1 minus 2. Yeah. Now I will do a minus lambda I. I'll do the algorithm. First, I find a minus lambda I. Then I find a minus lambda I square. That means I need to do the product of these two matrices by itself, matrix by itself. So that will be 4, 0, 1, 0, minus 8 plus 8, 0, minus 4 plus 4, 0. It should be 0. This is scalable, which is not in this course. Okay. So now I will choose U1 to be 1 and 0. I'm sure it will work because this is, they have in the first column is they are not zeros. So I have a minus lambda I times U1. This will be my U2. Yeah, I need to choose U1, not a minus lambda I U1 square, that is 0, but a minus lambda I U1 is not equal to 0. So I need to find now U2 as a minus lambda I U1. What is a minus lambda I 2, 1 minus 4 minus 2 times 1, 0. Yeah, so the first column will not be 0. Okay, so this is my U2. So it will be x1. X1 will be U2 e to the power. What was the lambda? 5 t. And that is minus 2 minus 2. And this is 2. Yeah. That is E5t. I have x2. That is what? U2t plus U1 E5t. That is 2 minus 4t plus 1, 0 E5t. This is what? 2t plus 1 minus 4t e to the power 5t. What is my general solution? X will be C1 x1 plus C2 x2. Yeah, that's it. You can rewrite it, do the other calculations. Okay. Let me go to the next one. Now this is 3 by 3. Okay, let me do the calculation. I have a minus lambda I. That will be, what kind of numbers these are? Minus 90 That's okay. 4 minus lambda 0. 3 minus 1 minus 11 minus lambda. Very clear. I will take the second. I'll do the expansion with the second row since they have zeros. So that will be 4 minus lambda. What is the rest? Be careful. Let me do it carefully. 22 minus lambda. I cancel the second row in the second column. I have minus 90. 3 minus 11 minus lambda. And what is that? Yeah. Be careful the calculation. Lambda square. 11 lambda minus 22 lambda. That gives me minus 11 lambda. Yeah, minus 11 lambda. Yeah, so this is 4 minus lambda. Lambda square minus 11 lambda. What we have here? 22 times 11. What is that? Yeah, I can think of it as 2, 11, 11. And they know 11 times 11, 121. That will be 242. So it is plus 242 minus what? Plus. This is minus, sorry. But it's minus 11 times 22. So it's a minus sign. And this is plus 270. So it's 4 minus lambda. Lambda square minus 11 lambda plus 28. Which is 4 minus lambda times lambda minus 4 lambda minus 7. So this is equal to 0. So lambda will be what? 744. Now for lambda equals 7, should be easy one. You have what kind of matrix? 22 minus 7, that will be 15 minus 6 minus 90. 0, 3, 0. Minus 3. Sorry, minus 3. Will not make a difference. 3 minus 1 minus 11 minus 7, that is minus 18 times K1, K2, K3 equals 0, 0, 0. So what are we getting? We are getting 15 K1 minus 6 K2 minus 90 K3 equal to 0. I have minus 3 K2 equal to 0. Plus K2 equals 0. Okay. That's 3 K1 minus K2 minus 18 K3 equals 0. I know that K2 is 0, so cancel. Yeah, these two are the same. Yeah. K1 is 6 K3 in both. So I have K1 equals 6 K3. Let K3 equal 1. You get K1 equals 6. So V1 will be 6, 0, 1. Only one eigenvector. And D will be 3 minus 1, which is 2. Perfecto. Okay. So now I need to choose U1 says that what A minus lambda I U1 cubed is equal to 0. But A minus no, what is this? Sorry. I'm going where? No, this is my mistake. No, this is not correct, huh? What is the defect? No, I have only one eigenvector. That's it. I have only one. This is for 7, huh? Yeah, this is for 7. Ignore it, huh? Now, so this is X1 will be V1 E70. Yeah, that will be my first solution. Now for lambda equal. Now we'll see what will happen. Okay. We'll do the same. 22 minus 4, that will be 18. Minus 6 minus 90. 0, 0, 0. 3 minus 1 minus 15. Okay. Times K1, K2, K3 equals 0, 0, 0. What are we getting? we're getting 18K1 minus 6K2 minus 90K3 equals 0, and 3K1 minus K2 minus 15K3 equals 0. And then the second equation is 0 equals 0, which is nothing. If you notice, multiply by 6, this is will be 18 minus 6 minus 15 times 6, it's 90. So these two equations are the same. So I'm getting that K2, I can write, sorry, I write K2, take the other side as 3K1 minus 15K3. So I have two free variables. I can get two eigenvectors, two linear independent eigenvectors. So we'll do this trick. Let K1 equal 1 and K3 equal 0. Let K1 equal 0 and K3 equal 1. What you will get here, K2 will be 3. So my V2 is what? 130. And my X2 will be V2 E40. This one, I'm getting K3 equals what? 15 minus 15, sorry. So V3 will be what? 0. This is K2. This is K2. So it's K1 is 0, K3 is 1 minus 15. So that will be minus 15, and K3 is 1. So it will be my third solution, V3 E40. What will be my general solution? X will be C1 X1, C2 X2, plus C3 X3. And this is equal to what? C1. What is V1? 601. 601 e to the power 70 plus C2. What is V2? 130. 130 e to the power 40 plus C3 0 minus 15 1 e to the power 40. Okay, let me do another one. Well, see what is different in this one. Okay, find the eigenvalues. Minus 1 minus lambda 0 1 0 minus 1 minus lambda 1 1 minus 1 minus 1 minus lambda. Okay, so take minus 1 minus lambda. It's this with this. I have what? Minus 1 minus, yeah, minus 1 minus lambda 1. Okay, plus 1. Cancel third row and first column. I have 0 1 minus 1 minus lambda 1. That will be what? Yeah, minus 1 minus lambda times lambda square plus 2 lambda plus 1. Here I have plus 1. This is 0 minus this, minus 1 minus lambda. Now if I take minus 1 minus lambda common factor, this is minus, sorry, minus 1, since it's 0 minus this. Okay, if I take this as a common factor, I have what? Lambda square plus 2 lambda plus 2 minus 1, which is plus 1. So that gives me minus 1 minus lambda, lambda plus 1 all square. So I have lambda minus 1 minus 1 minus 1. Okay. Let's see what will happen now. Yeah, for lambda equal minus 1, how many eigenvector I will get? Minus 1 minus minus 1, that will be 0 0 1 0 0 1 1 minus 1, 0. Okay. One minus 1, 0, yeah. Times K1, K2, K3 equals 0, 0, 0. So you have what? K3 equals 0, K3 equals 0, K1 minus K2 equals 0. So you have K1 equal K2. So let K1 equal 1, K1 equal 1. What will be my V1? 1, 1, 0. Which is, we have only one eigenvector. That means D3 minus 1, which is 2. Okay. So I need to choose now. Choose U1 A minus lambda I cubed. U1 equals 0. But A minus lambda I square times U1 not equal to 0. Okay. I have to find A minus lambda I square. That will be A square. That is, what is it? 0, 0, 1, 0, 0, 1, 1 minus 1, 0 by itself. That will give me what? That will give me 1. First row times first column, first row times second column minus 1, first row times the third column 0. First row, the same thing with the same row. Now the third row, it will be 0, 0, 1 minus 1, which is 0. Now what will be A minus lambda I cubed, which is 0, 0, 1, 0, 0, 1, 1 minus 1, 0 times the square, which I just get. That will be what? 0, 0, 0, same. This is 1 minus 1, 0, minus 1, 1, 0, 0. So let U1 be what? I want to time this not equal to 0 and time this 0. I have no restriction here because A minus lambda I cubed is 0. So I can choose U1, 1, 0, 0. What will be U2? It will be A minus lambda I U1. That give me what? 0, 0, 1, 0, 0, 1, 1 minus 1, 0 times 1, 0, 0. If we do that, first row will give me 0, second row 0, the third one 1. And what will be U3? It is A minus lambda I U2. That will be 0, 0, 1, 0, 0, 1, 1 minus 1, 0 times 0, 0, 1. Oops. 1, 1, 0. Yeah. Now my solutions, x1 will be U3 A minus t, which is 1, 1, 0 is minus t. X2 will be what? U3t plus U2 A minus t. What is U3? Is 1, 1, 0 t plus 0, 0, 1 A minus t. And that will be t, t1 is minus t. Okay. Yeah, that will be TT1. Yes, yes. Now we'll find, yeah, X3 will be U3 T square over 2 plus U2T plus U1 E2 minus T. Yeah. 1, 1, 0 T square over 2 0, 0, 1 times T. What was U1? 110, 100, I mean, times E minus T. That will give me what? T square over 2 plus 1 T square over 2. And the last row, 1. T square over 2 plus 1 T square over 2. Last one T, not 1, sorry. It will be T. Okay. Don't forget E minus T. And what will be my general solution? X will be C1 X1 plus C2 X2 plus C3 X3. Oops. Now we'll go to the next one. We have two to go. Let me try to do them quickly. I have A minus lambda I minus 1 minus lambda 0, 1, 1 minus lambda minus 4, 1 minus 3 minus lambda. I'll do the expansion of the first column, minus 1 minus lambda. Yeah, let me do the rest quickly. I have lambda square, 3 lambda minus 2 lambda, minus 3 plus 4, that will be plus 1. So it will be minus 1 plus lambda, 1 plus lambda square, which means lambda will be minus 1 minus 1 minus 1. So I have minus 1 of multiplicity 3. Check how many eigenvectors I'm getting. To check which format I will do. Will lambda equal plus 1. What will be the formula? Will lambda equal minus 1, sorry. Minus 1. That will be 0, 0, 1, 0, 2, minus 4, 0, 1, minus 3 plus 1, that is minus 2. K1, K2, K3 equals 0, 0, 0. So I have what? K3 equals 0. I have 2K2 minus 4K4 equal minus 4K3 equals 0. And K2 minus 2K3 equals 0. Since K3 equals 0, for sure I'm getting here K2 equals 0. So I let K1 equal 1. So I have only one eigenvector. Only one eigenvector. So it will be D. T will be 3 minus 1, which is 2. Great. Okay. Now it means I need to choose U1 such that A minus lambda I cubed is equal to 0, but A minus lambda I square U1 not equal to 0. Let me find A minus lambda I square and cubed. I have A minus lambda I square. That will be 0, 0, 1 minus 2 by itself. Yeah, what you will get? You will get 0. This times this, you will get 1. This times this, you'll get minus 2. Now I have 4 minus 4, 0. I catch 0, 0. And what's minus 8 plus 8, 0. Yeah, this is the same, 0, 0, 0. What will be A minus lambda I cubed it will be this matrix times this. What you will get? First row, first column, 0. First row, second column, 0, 0, 0, 0, 0, 0, 0, 0. Yeah. So can I choose? I cannot choose U1 to be 100. We cannot choose. U1 to be 100. Why? Since A minus lambda I square U1 will be 0, 0, 0. I don't want this from here. So choose U1 to be 0 and 0. I think it will work. Yeah, with A minus lambda I square, what will happen? Need to check it's not 0. You have what? 0, 1 minus 2, 0, 0, 0, 0, 0, 0, 0, 1, 0. That will be what? The first row, that will be 1. That's what I want. So it's not 0. So it's okay. So choice is okay. U2 will be A minus lambda I U1. What is U2? What is this? Is 0, 0, 1, 0, 2, minus 4, 0, 1, minus 2 times 1, 0, 0. That will give me what? 0, 0, 2, 1. Yeah. And what will be U3? U3 will be A minus lambda I U2, which is this one actually. And I'm multiplying A minus lambda I square. Okay. That, let me do it. 0, 2 minus 4, 0, 1 minus 2, 0, 2, 1. This is 1. Then you have 4 minus 4, 0, 2 minus 2, 0. Now solutions, x1 will be u3 x minus t. What is u3? 1, 0, 0, e was minus t. x2 x2, it will be u3t plus u2 e minus t, which is equal. Let me do it right away. Let me do it in a step. 0t plus 0 to 1 all times s minus t. That will be t to 1 s minus t. Check. T to 1, yes. x3 will be u3 t square over 2 plus u2t plus u1 s minus t. And that will be, what is u3? 100 t square over 2 plus 0 to 1 times t plus 100 s minus t. That will be what? T square over 2 plus 1, 0, 2t, and t. No, choose U1, sorry. My U1 is 0, 1, 0. So there is no one here. The 1 should be here. Is minus t. Let me do the last one. Those are suggested problems. Mostly I did the suggested problems, except maybe one. Okay. So let me do A minus lambda I. Find the eigenvalues. I have 1 minus lambda 0, 0, minus 2, minus 2, minus lambda minus 3, 2, 3, 4 minus lambda. I'll do the expansion of the first row. So I have what? Here I have lambda square minus 4 plus 2 minus 2 lambda. Okay. Minus 8 plus 9 plus 1. So it will be 1 minus lambda. Lambda minus 1 square equals 0. So I have lambda equal 1, 1, 1. Now for lambda equal 1, what will happen? You have 0, 0, 0, minus 2, minus 3, minus 3. I have 2, 3, 3. Very clear. I have only one equation. 2k1 plus 3k2 plus 3k3 equals 0. So I have two free variables. Very clear, I have two free variables. Let me say k, make it like this, k1 3 over 2 k2 minus 3 over 2 k3. So my free variable k2 and k3. Yeah. If that is the case, so I let k2 to be 1 and I will not let k2 equal 1. I let k2 to be 2. I let k2 to be minus 2 actually. And k3 equals 0. I let k2 equal 0 and k3 equal minus 2. Yeah, to avoid the fractions. So what I will get in this case, k1 will be 3, and the same thing here, k1 will be 3. So I have two eigenvectors, v1, 3 minus 2, 0, and v2, 3, 0 minus 2. So I get two solutions now, x1, v1e, what is lambda t, which is 3 minus 2, 0, et. The second solution, v2 et, which is 3, 0 minus 2, et. Yeah, so I have two eigenvectors. I mean, D independent for sure. So D will be 3 minus 2, which is 1. Now to find the third solution, we'll choose U1 such that A minus lambda I square times U1 equals 0, but A minus lambda I U1 not equal to 0. Okay, let me do the calculation. What will be A minus lambda I square? That will be what? What is A? 0, 0, 0, minus 2, minus 3, minus 3, 2, 3, 3 by itself. What you will get? First row, no problem. Second row, it will be 0, 9 minus 9, 0. Yeah. First row by the first column, 0. Second column, third column, all of these are zeros. Now this one by the first row, it will be 6 minus 6, 0, 0, 0, and the rest is the same. So let U1 equal 1, 0, 0. It will work. It's okay. Actually, this one, anything. Also, a minus lambda I. Check a minus lambda I times u1. That will be what? 0, 0, 0. That is 0 minus 2, 2. And by the way, this is u2. So I'm checking this one. u1 is good, and I'm getting u2 right away. So it will be my third solution. It will be u2t plus u1 e to the power t. Oops. What is u2? 0 minus 2, 2 t, and u1 1, 0, 0 at. That give me what? 1 minus 2t, 2t e to the power t. And my general solution, x will be c1 x1 plus c2 x2 plus c3 x3. Yes, I'm done now with 7.6, where in this video I cover questions from the book, especially the suggested problems. And the next videos, I will start chapter 8, inshallah. Let me stop the recording. Thank you.